Yeah. Good morning, students. Welcome back to Physics 102 class. In our previous lecture, we highlighted the quantitative aspect of electrostatics, that is Coulomb's law. You remember, we break it down into simple terms and explain some of the assumptions about the law. For instance, we mentioned that the law is valid when charges are point charges. We mentioned that charges remain stationary. We also mentioned that the medium must be homogeneous or isotropic. The separation distance is much larger than the size of the charges. So these are some of the conditions. And we also highlighted that if you want to solve a problem related to this, you have to draw a clear diagram, identify all the forces, and also use the Coulomb's law for each pair of the charge. Then you can resolve into components if needed. Okay? So, as we promised in our previous class, we are going to use what we call superposition principle to add up all these vectors. In the case when there are 3, 4, or even millions of charges acting on one point. Okay, so what is the superposition principle? What is it telling us? Okay, this principle is applied when several charges acting or act simultaneously on a test charge. So the net electrostatic force is the vector sum of the individual forces exerted by each charge along the line. Okay? Or alternatively, you can tell that the net electrostatic force on a charge due to several other charges is the vector sum of the forces exerted by each charge individually. So the contribution of each charge is taken care of by the force. Okay? So, as I mentioned, we can see from the slides, we have shown mathematically that F net is this total sum of the individual forces. So you can say that F net, that is the final force or the effective force, is equals to F1, F2, F3. You can say that F1 plus F2 plus F3 is equals to F net. Okay? Because the electrostatic force obeys the principle of superposition. So this principle allows complex charge distribution to be analyzed by considering each charge, as I mentioned. So some examples were given, as you can see from my slides. Okay, we are to find the net force on Q3 due to Q1 and Q2. Example 1. All right. So here, if you look at this problem, we have already explained about the like charges. We have talked about the repulsive force. We have talked about the attractive force, right? So here the Q1 is given and the Q2 is given as well as the Q3. And their distance of separation respectively given as 3 meters and 4 meters. So from the solution, you have to apply the formula F, that is the force from, we can say that, okay, force on Q3 due to Q1 is a repulsive. We have no issue with this because Q1 and Q3 are what? A repulsive force. The charges on, the force on this is repulsive on these charges. Okay, so we substitute the value and obtain 8.0 times 10 to the power minus 3 newtons to the right. Why to the right? Because the Q1 and Q2 are what? Are repulsive, have a repulsive force. Okay? And Q1 is due to, Q3 is due to Q1. Okay? So force on Q3 due to Q2 is attractive from the figure. Okay? I can show you with some pointers so that you can see clearly. So here, Q2 the force on Q3 due to Q2 is attractive, but the force on Q3 due to Q1 is repulsive. This is what we are saying. Okay, so we have found the value for the the force on Q2 due to Q3 or Q3 due to Q2. This is the attractive force. So if we are to calculate the final force on this, we have to add the sum of all the forces. That is the force on Q1 due to Q3, okay, plus the force on Q3 due to Q2. This is what we found. So alternatively, if you look at this figure, the total sum of this force, that is the force on Q3 due to Q1, is a collective force that attracted or that gets attracted to the force on Q2. So whatever we have here is attracting to this, that's why we say to the right. So it's shifting towards the attractive side of Q2. It's a straightforward example if you look at it, okay? So we have other examples, but before then, you can see that some of this important summary you have to recall about the Coulomb's law, the expression for the force. If you are dealing with a single or one-dimensional problem, you can just apply a normal formula. But in the case where you have maybe a 2D arrangement of the charges, you can apply the vector sum and also find the total or the net force. So the superposition is just telling us that we need to combine the influence of the force on the charges due to several other charges, because the one charge at a point is attracting various charges in the in space. Okay, so this is all about the superposition principle. So you have to recall the concentration of a charge and some of the constants are given. So you can see the formula here, the K, the constant of proportionality 1 over 4 pi epsilon naught is given. You have to recall this all the time, and the epsilon naught, the value is 8.854 to the power minus 12 Coulomb square per Newton meter square. And this is the the charge, okay, electron. Okay, so what is important for this lecture today, you have to take notes about the net force is the vector sum of all individual forces due to other charges, as you can see here. Okay, and remember also, like charges repel, unlike charges attract, as you can see. Okay, so next let's quickly see the next example, okay, this example is the correct version of 2.3 from the lectures note we have shared last time. Okay, the PDF file. So the F-net, as we mentioned now, is the total sum of the individual forces. So we have a correction from that example, and the final answer for the net force is given as 0.81 Newton, because since Q3 is to the right of Q1. Yes, Q3 is to the right of Q1. So the force Q1 is towards the left, that is to the negative direction. However, as you can see in the adopted notes we have provided, we shared in the group, if you remember, the net force was written as 0.618 Newton. This is this is not correct. So okay, so you have to effect this correction, so that anytime we want to solve a problem, we have to be mindful of in solving this kind of problem, so that we may not have issue on the total or final answer we are trying to solve. Okay, all right, so there are various examples that we can share. Maybe in the group I will subsequently scan and send it to you, so that you can see, or you can solve by yourself before our meeting. All right, thank you for today. See you next lecture. Bye bye.